Hello, this is Alison, welcoming you back to the Gardening by Design box of tricks, where we're looking at how to choose plants that will thrive in your garden. In the first video, you saw that 4 key factors underpin the conditions that a particular plant needs. In part 2, we're looking in more detail at the requirements of water and nutrients, and how the soil in your garden influences these. So I hope that in the meantime, you've got to grips with your soil, possibly literally, as one of the best ways to assess soil type is to pick up a handful and give it a squish. Right plant, right place. Part 2, not just mud. You already know that plants take in water, oxygen and nutrients, and for most of the plants in our gardens, this means that the soil needs to contain these 3 things and make them available. So not surprisingly, we're looking at soil rather more closely to understand how the type, basically what it's made of, affects them, starting with water. Clearly how wet or dry your soil is depends primarily on how much water reaches it in the first place. So there are some basic questions to consider for your own garden. Are you in a high rainfall area or a very dry spot? Do you have a permanent source of water seeping into the soil, for example from a stream, pond or natural springs? Does the border slope so much that the water runs off before it sinks in? Or is the reverse true, where water drains down into your garden or border from the surrounding land? And finally, are you willing or able to water the garden in dry periods? But equally important to understand is what the soil does with whatever water it receives. The amount of rainfall can result in very different soil conditions for your plants, depending on what the soils are made of. And that largely depends on where you live. So, let me explain. By the way, one thing to make clear at the start is that I'm talking here about the soil out there in your borders, and not the multi-purpose compost that we might use for summer pots and containers. This prepared compost consists entirely of rotted down plant material, referred to as organic matter, whereas the characteristics of your garden's soil come largely from the mineral content. In a good topsoil, called loam, there is a balance of 3 key minerals, sand, clay and silt, that together create the ideal texture. But in most garden soils, you have a lot more of one of these than the others, and that changes the texture and the water and ultimately the nutrient levels. So, how do you know what you've got without peering down a microscope, which actually is rather more interesting than you might think? Well, that is why I suggested at the end of part 1 that you take a handful of typical soil from your border and roll it into a ball with a few drops of water if it's dry, and then squish it between your fingers to feel the texture. Here's how. I have 2 samples of soil here from my own garden, so we'll do the squish and feel test. It's nice and moist already because it's been raining. So squish this one together, open it out, and you can see that it's really clinging together. You can see when my fingers have squashed it, and if I push it, again, it's smooth, it's quite sticky, and I can mould it a bit like plasticine or pastry. And that's telling me there's a high clay content in it, and that's my basic subsoil here in the garden. The other sample is a darker colour. Squeeze that one, again, squeeze it together the same, open it out. You can see that it's binding, so it is based on the clay soil, but if I touch it and try and rub it, it breaks apart into a much better crumbly texture. I can feel some sand, some grit, some little stones in here, and it's much more open. So that's how you do a soil squish test. At this point, I should say, of course, now please wash your hands. If the ball crumbles and feels gritty, then you have a high sand content. If the soil forms a fairly solid ball that can be moulded easily and feels smooth and sticky between your fingers, then you have a high clay content. If the ball holds together and feels silky and slippery and soapy, then you have a high silt content. But this is much less common than sand or clay. And now we have a bit of a Goldilocks moment. that holds together but cannot be moulded, and you can detect all the textures in between your fingers, then you have a balanced loam, which gives you the basis to grow the widest range of plants. Let's look a bit more at each of these minerals and how they affect the water in the soil. Sand has relatively big angular particles. You can actually see individual grains of sand in your hand. There are loads of spaces in between, and water drains through very quickly and then out of reach of the plant roots. Clay has microscopically small particles that are flat and cling together, preventing water draining through, so you get a stiff, sticky mess in winter and solid dry lumps in summer, with very few air spaces. Silt has small, smooth particles, not as tiny as clay, so the soil holds water well without waterlogging, but it is easily compacted and very quick to dry out in summer. So I'm sure you can see that the ideal is a balance of all three. Water and nutrients are held in the soil, but you avoid waterlogging, and there are plenty of air spaces to supply oxygen. So that's it for the primary mineral sources of the soil. But if the underlying rock is very close to the surface, this too has a big effect. In the UK, chalk, a type of limestone, forms hills and downs, and often the layer of recognisable soil on top is very shallow. 10 to 15 centimetres is quite good. You can see the grass almost clinging straight onto the chalk in this photograph of chalk cliffs. Water drains very freely through the porous chalk, so these soils will always be very dry and, as you'll know if you have one, very challenging. It's time for a quick summary before we go on to the practicalities of planting up these soils. Overarching everything is how much water reaches the soil, that's the water supply, and there's not much you can do about this apart from permanent irrigation, drainage or moving. Then comes the mineral content of your topsoil. Can you remember the three key components of the soil that I mentioned when you do the soil squish test? Yes, sand, clay, and less commonly silt. And finally, you need to consider what is below the layer of soil that you regularly dig and plant into. And what is the key question about this layer below? Drainage, whether it allows water to drain through easily, like sand and chalk, or much more slowly, like clay. Great, now with an understanding of how your soil deals with the water it receives, we can start to match plants to places. And as you discovered in part 1, there are plants adapted to growing everywhere, from ponds to deserts. If you want plants for wet soil, think of those habitats, bogs, marshes, streamside. And for dry areas, we have plants from mountains, dunes, and prairies. But you may need to take one more step before rushing off to buy suitable plants, because in general, plants want consistency, and that means a damper or drier soil all year round. And remember that clay dries hard in summer and dry and oozes wet and waterlogged in winter. Silt is dusty in summer but wet in winter with very little air inside. And sand and chalk are free draining and dry all year and may become extremely dry in summer. Now, I said earlier on that you can improve garden soil to balance out the natural behaviour. And the video clip, you saw my basic clay soil and the improved sample. So here are a couple of words about how you do it. Yes, whatever your garden soil challenges, organic matter can help as it acts like a sponge, holding water but releasing the excess, allowing air to percolate through clay, binding sand and bulking out shallow chalky soils. Organic matter, in the form of any well-rotted plant material, whether you make garden compost and leaf mould, keep chickens or buy in farmyard manure, is the key to that strange but true combination of a water-retentive but not waterlogged soil. And this improvement can bring your soil into the centre ground, neither a bog nor a desert, and keep it more consistent all year round, so that now we are ready to look at the plants. By the end of this topic, and after considering how each area of your garden supplies the key requirements of water, nutrients, light and warmth, you'll be able to choose suitable plants with the aid of books, the internet, and of course by reading the labels. But here are a few plants to whet your appetite, starting, appropriately enough, at the wet end of the scale. Plant cells need oxygen to burn glucose and release energy, just as humans do. And I have already said that most plants take in oxygen through the roots. But if the plant is growing in a pond, or the soil is saturated, there are no air spaces, and therefore no oxygen. So, how do you think plants survive? They survive because plants specialised for ponds or bogs are adapted to absorb oxygen through the leaves and transport it down to the rest of the plant. So you don't need me to tell you that if you have a pond, you need to buy pond plants. Boggy areas are a bit more forgiving, as long as there is not water sitting on the surface and there is drainage below. So if you have an accidental or deliberate bog garden, there are plenty of great plants for it. Some can grow either in shallow water or boggy soil, and these are often called marginals, such as these native yellow marsh marigolds, and Darmera, with its tall flower heads above a clump of rounded glossy green leaves. The delicate Iris sibirica is ideal for planting in boggy soil, but will also be fine in a damp border. But note this is a different species from the sun-loving large bearded irises, so check the labels. In complete contrast are the huge leaves of Gunnera that can grow up to 2 metres tall by the end of the year and dies back in the winter. Moving up the scale to good, rich, moisture-retentive soil that doesn't dry out in summer, there are many plants that we see in normal border soil, but that do much better with more water. One of the key features of moisture-loving plants like this hosta is large leaves. Plants lose water through the surface of their leaves that has to be replaced by uptake through the roots. The more water is available at the roots, the bigger leaves the plant can grow without suffering. So your hostas will be much more luxuriant in a damp soil. The coloured stems of dogwood, this one has variegated leaves for summer interest too, and willow are also naturally found in damp waterside locations. Willow has many varieties, but Britsensis has lovely orange stems in winter. And astilbes are another plant, familiar from the border, that are more vigorous and happy in damp soil. Colours range here from cream through pink to red. At the other end of the scale is dry soil that's free draining even in winter. There are many shrubs, along with hardy perennials and grasses, such as those used in this prairie style planting, that are happy in dry soil once their root system is established. I explained that plants suited to boggy places often have large leaves because water loss is not a problem. So if you need plants for dry spots, what adaptation might you look for? Well done if you said reducing water loss through the leaves. And this makes sense because there is so little water around the roots to replace what is lost. Plants from dry habitats often have small leaves. Some are needle-like and small and waxy to reduce evaporation, like this leptospermum with the red flowers at the back of the photograph. And many are just very small and ground-hugging, like the creeping thyme in this herb garden. The bees love the tiny mauve flowers. Another visual guide to plants that may be drought tolerant is grey leaves. Lavender is probably the most well known. In fact, the leaves are green, full of chlorophyll, but they look grey because a covering of tiny hairs traps air and reduces water loss. Eryngiums take a different tack. They have thin, spiky leaves. Basically, the plants are spiky all over, and they love dry conditions. The genus includes the UK native sea holly that even grows on sand dunes. Well, that's the end of the section on water in soil. Next comes a look at how soil affects the availability of nutrients, and this means revisiting sand, clay and chalky soils. So here's a quick recap. Sand drains very quickly but is easy to dig and can become very dry. Clay is impermeable, especially when wet, but rich in nutrients. And chalk is often very shallow soil, but free draining. And all are improved by adding organic matter. If you ask a gardener about their soil, the answer is likely to cover the main component of sand, clay or chalk, and some reference to the pH. pH is the scale used to measure how acid or alkaline the soil is. You may have noticed that soil pH is a topic of much writing, instruction and interest to gardeners in relation to what plants you can grow. So why am I talking about nutrients instead of pH? Well, plants need nutrients, that's what the soil has to supply. The pH becomes important almost as shorthand because it affects what nutrients are available to the plants. Now, this can get as scientific as you want to if you delve into it, but I'll stick to the practical implications in this topic. The pH scale measures the acidity and alkalinity of anything, and it runs from 0 to 14, with anything recognisable as garden soil usually between 6 and 8. In the great scheme of things, the variation in pH between soils is not very wide. To give you an idea, battery acid is at 1 and bleach is at 13, with 7, as you might expect, in the middle being neutral. So even when a soil is described as acid, don't worry, you won't burn your hand by sticking it in. So where does the pH, the acidity and alkalinity in the soil come from? Well, this is where it gets a bit circular, because several of the same chemical elements that are important as plant nutrients are the ones that determine the pH. Primarily calcium, magnesium and potassium, which are all alkaline. So if the soil contains high levels of these, then the soil becomes alkaline. Whereas low levels of these, especially coupled with lots of organic matter, may result in a slightly acid soil. And you can see from this slide that the three main soil types each have a different basic pH depending on the levels of those alkaline elements, especially calcium. By the way, I'm showing the pH arrow changing from green to yellow, as this is how the colours appear on a basic pH soil testing kit. Starting from the bottom, sandy soils are, as you know, very free draining, and the calcium, which dissolves in the water, is easily leached out. Bit at a time, whenever it rains, and eventually the soil moves further to the acid end of the scale. Leaching also means that sandy soils can become deficient in a range of nutrients and need regular feeding. This is why organic matter is so important. Wet soils with a high organic content, such as a peat bog, are also acidic, and that's a side effect of the decomposition, but you're not likely to get that far in your own garden. Clay in the middle is usually neutral, but it can vary depending on what's underneath, so you may want to test it. If you buy in prepared general purpose topsoil, this should blend all the key elements into a neutral mixture. And chalk. Chalk is a form of calcium, so a shallow soil over solid chalk, or one where a lot of chalk fragments have come to the surface, is going to be strongly alkaline. Of course, chalk is also free draining, so as with sand, nutrients will leach out. But in this case, it makes absolutely no difference to the pH because there is an endless supply of calcium just below. And now we get on to why all this matters to your choice of plants. Firstly, looking at the acid sandy soil. This is the home of what are referred to as ericaceous plants, including this Acer, here in all its autumn glory. What is worth understanding is why this group of plants grow best in slightly acid conditions. And this takes us back to calcium. Calcium in the soil binds onto another vital nutrient, iron, and prevents it from being absorbed by the plant roots. It follows then that if there is a high level of calcium, there will be much less iron available, and ericaceous plants, such as camellias, are particularly sensitive to this and suffer. Iron is needed for the leaves to make green chlorophyll, so the plant leaves turn yellow and the plant cannot photosynthesize. This is something that you've probably seen, and now you know why. All the azalea and rhododendron family also grow most happily without too much calcium. But you can sneak them onto neutral clay with an annual dose of a specialised fertiliser containing extra iron, now that you know how it works. As well as holding onto water, clay particles hold on to the nutrients. So once organic matter has been added and the soil is workable, they are very rich and productive. So it's great for hungry plants that need plentiful food and water, like roses. Hydrangeas too like the generous moisture, and these lace caps do not change colour depending on the soil. The neutral pH gives you a wide range of flowers to choose from, including large flowered clematis that really don't like an acid soil and need it neutral or slightly alkaline. Chalk soils are always challenging, but there are plants that will be happy, many of which come from limestone mountains, chalk grassland and cliffs. If you add a good deal of organic matter to increase the soil depth, water and nutrients, the choice is extended. Look for plants that enjoy a dry spot, such as this erysimum, the perennial wallflower. Euphorbias add structure ranging in height from 15 centimetres to well over a metre. And some shrubs, such as pineapple broom, also thrive on alkaline chalky soils. Similar to the effect on iron in the soil, alkaline soils trap the trace element aluminium, and aluminium is needed for mophead hydrangeas to produce blue flowers, and without it they revert to pink. And here we are at the end of this video, after looking at how your soil affects the plants that will thrive in your garden. There are two threads to this. Firstly, how the mineral content and particle size governs whether water and nutrients are held in the soil or drain away quickly and leach through. And secondly, how the level of key elements, especially calcium, drives the acidity or the alkalinity of the soil, and how that pH can make key nutrients less available, impacting particular groups of plants and influencing what will thrive. And now it's homework time again. You'll be going back outside to look at each area of your garden and note down how much sunlight reaches the plants at ground level. None at all, part of the day, or all day in full sun. And is the spot sheltered by a wall or a fence or a hedge, or is it exposed to winds and winter weather? Then comes a tea break. When you come back to part 3, we'll be looking at the influence of the garden's situation on the remaining factors above ground of light and warmth. And as always, there'll be some plant suggestions to look at. See you soon.